Let me share screen so we can have it on video. Okay, so I'll post the video maybe tonight or tomorrow. I'll get them up as soon as I can. So this week we're going to cover chapter 3. We'll talk a little bit more about evidence and artifacts. And the type of evidence we're going to be working, right? So I was driving into work today and I heard on the news that they had found a suspect for that fire line that's happening in San Francisco, right? And one of the areas that they looked at was through data and digital information. So they did forensics to be able to find, and it turns out to be a UPS delivery person. They found some evidence in his van, his work van at his home. But they, they have surveillance camera data, they have a bunch of stuff. So crime analysis team, along with the computer forensic people, right, they had gone through. So they probably were able to pull like geolocations and things. So that's pretty neat. So it's useful in many different ways. So we'll talk about evidence today. Now, evidence is going to be determined based on the facts that you obtain on the system, right? Whether we're looking at drives or we're looking at cookies or we're looking at email. So it's really important that we go into it neutral, like what we talked about before, and we have proper evidence handling procedure. So how should we handle our evidence? For the first question, it says, how should you handle your evidence? We want to make sure that we have chain of custody. Is that too small? Can we see? Do you need me to zoom in? Let me make it. It is at 200. Okay, it's less than 200. Okay, that's better. So we want to have proper procedure for chain of custody and follow that. That means that if you acquire an iPhone, right, you take a picture, you write down the model, you put the time, you put down the name, and then if that gets passed to the next investigator or someone else is looking at that system, or you're investigating that system, you would then make sure that that gets documented, right? We want to make sure our evidence is tracked, recorded, and reported. And then we want to have it properly secured. So that means that sometimes we have to do bag and tag. We talked about that before, put it into a secure container. And then storage. And storage facility can also vary. We would have something that is, safe, or not having someone tampering with our evidence. So you have to have secure locks on doors, fireproof sometimes. So while investigating, you want to make sure that your evidence is not tampered with.
Well, in this case, you said make sure it's tracked, secured, and what else?
And protected. Yeah, we will have to report all of that in when we write up our report, right? And sometimes that if it's a legal matter, it would have to go through litigation process and all of that. So we want to make sure that we are clear, we have the proper facts, but ultimately we have to secure and handle it properly. So before we get into number 2, let's go back to the notes. Okay. So proper procedures and methodologies is important, right? Important that we don't take shortcuts. Okay. So all the steps you need to document, all the steps you need to follow, and we need to validate any procedure, methodology, and process. The tools that we use, we talked about tool validation before, maybe using technology like a website If it's tested already, you gotta make sure that you note that on your report. As you go through it, you would say that this tool has been tested by this entity. And also you need to validate any procedure. So in the validation process, you cannot rely on a company that did it already. So even if NIST validate your tool, you also need to validate, right? Like when we using a tool, we want to make sure that that tool is reliable. Okay. So how does validation work? Like I said before, if you do the same step and you produce the same result, so let's say that I'm looking for a malware, right? A ransomware that got into the network, and that ransomware just took over and locked a few of my systems or maybe a segment on the network. When we go through the process, we would use multiple tools to be able to try to produce the same result. And then we repeat the same process, the same procedure, right? Using the same tool. So you don't do it once, you do it multiple times. And you want to get the same conclusive finding, that malware, that name, that ransomware, and it impacted these systems, right? So your network capture and along with, malware analysis tool. So we'll use Wireshark today to look at that, right? So you need to go through the same step to answer the same questions, and you need to have the same result. That means that it's validated, okay? And this takes patience and effort, like I said, a little different than some of the other work that we see in IT and cybersecurity. So what should you do to validate procedures and processes? You should repeat the procedures step by step to produce the same result. If you have different results, then you can double check again and try it the third time, but if you don't get the same result, then it's not validated. So the more detail oriented we are, right, the more careful we are, because sometimes it will take time, and you have to repeat things to find the details, and it can be a very small detail that's going to give you some clue or fact for that particular case. So we have to be methodical about our procedures, right? I don't want to jump from step 1 to step 10. Remember, no shortcut, right? We want to be methodical. We wanted to look at like what makes sense to go from step 1 to step 2 to step 3 and so on. Okay. So like I said, so what does it mean? We want to take the image of your actual system, right? We talked about not turning things on or off because that can change the state of the system. So you have to think things like that, like I should not shut down the system. I want to be able to capture the live image, transfer it to another drive, and then make a copy of it in case that drive is corrupted, right? So you have to kind of lay out your steps. And then for each step, what is your goal? What are you trying to find? Okay. And if we are methodical and thorough, that's going to reduce the error that we're going to run into, right? So the mistakes in our investigations, and that mistake can also be used in court. So we want to make sure that everything is accurate, because it is a livelihood of someone if it's a criminal case, right? If your evidence pointed that that person is guilty, then that person can be in prison for a long time. So we want to be fair and careful. Any question? So with that, we need to perform in a forensically sound examination environment. Not just having the tools and the technology, but making sure that we have the proper procedures validated and we are careful and accurate. Any questions? Okay, so where can I find this information? Right here, you can find it on page 1 of our notes, right? If you have the book, you can also read it in chapter 3. So we need to have control of our working environment. And then you would have an intention in how you would carry out your actions. So I mentioned this last time and a little bit earlier as well. We talked about tool validation. So for a lot of the forensic examiner, especially in this technology area, as you know that it changes quickly, open source or proprietary tool, they get updated, like software tools or hardware tools, they get updated frequently. So we want to make sure that we keep up with our skill sets. That's very important. So certifications, training, and recertification is important. You also need to know a little bit of programming and coding because some tools require that. So the technical aspect of this is not just using applications and finding things, but sometimes we have to use a script, right? We have to use certain tools. So artifacts can be found in a lot of different things. And then for the file system or the operating system, that's also important. So meaning what? Your file system, like in Windows, that will be your NTFS, right? Or if you're using, if I'm examining like a USB drive, that could also be EXT-FAT or FAT. So knowing operating system is also important. Okay. And then for your validation area, you would create a checklist and looking at specific tools. So I tell students and people this all the time. Cybersecurity is about using tools effectively, okay? And knowing when and how to use it and what to use it for. So having the tools on your tool belt, a list of tools that you use for specific things is important, but you have to maintain that list. You have to keep up and finding out if that tools get updated or removed, okay? So you need to understand the functionality of the tool, okay? You need to make sure that you know how to use the tool effectively. So documentation is really important, especially open source. So before you use the tool, even before you download the tool, read about the tool, research about the tool. What are the flaws, right? What if the software tool that you use have a lot of flaws? Okay, and then you start using it maybe for 2-3 days or 2 weeks, that could waste your time. Okay, even if it's highly rated, sometimes you run into tools that, you know, that could not be beneficial. And then you would take notes during the examination and validate your tool. Okay, so additional information here. Now, you cannot testify for someone else's validation. You can only testify for your own validation. Okay. And when we refer to forensic images, we call that as a data set. Okay, because it contains pieces of data. It could be files, right? It could be text messages. It could be a lot of different things. And you would ask these questions. What happened if your tool get a different result using the same method and the same tool? Okay, so for this data set, you can go here. There's a lot of practice data sets. It's pretty cool. You can check it out. So during this class or after this class, you can continue to practice. Okay, so we talked about validation. We want to be proficient, right? We want to be knowledgeable and be able to use the functionality of the tool, the features, and then you have to continue to train. Okay. So let's go to the next few questions. Question 4. Why should a digital forensic examiner pursue continuing education? To be aware of changes in tools and practices in the field. And this goes across for all cybersecurity professionals. You know that malware is always changing. People always come up with different breaches and techniques. There are different tools, exploit kits that are being developed all the time. So continuing training and education helps us keep up with the field, right? Be more aware of what we need to use and how we should use it. Now, even if your job entails the same thing over and over again, but you might run across a little bit different situation or problem. So having the flexibility. Now, when you go through, even whether you're a pen tester or a forensic professional in this area, you would see that, thinking outside of the box, critical thinking skills is important. So some of that goes back to some of your basic skills, right? Communication skills. But the technical tools, because, it is a very fluid and dynamic industry, there are new tools that are created, and then some of the stable tools, right? You want to keep up and learn it and do well in it. So the more expert you are in some area, the better that's gonna be. But you also have to be diverse in your knowledge, right? You have to know additional things, so that way, in the case you run into problems in those areas, you're able to handle it. And you can find also answer for 5 from the notes. You can grab that or retype it. So we need to understand the tool functionality, right? Dr. Nguyen will not be there to tell you step by step on what to do like a lab procedure. So I will tell you this. When we do lab, it's gonna be like one set, we're done, we move on to the next lab and learning topic. And a couple semesters from now, you kind of remember what you use, but you might have forgotten how to use it. It's about practice, and the same thing for programming. I tell my computer science students, you can write a good program one time for one course, but it doesn't make you a good developer or an engineer. Right? You have to continue to refine and fine tune your skill, just like everything else that we do every day. Right? If you learn to cook, you might do okay or bad the first time, better the second time, and maybe really, really good 1,000 times in. So it's about fine tuning your skill sets over time. Okay. Because taking the course and getting certifications, I've hired people that got tons of certification. And when it comes down to doing the work, some of them don't stand up, right? So it's about standing up to what you have earned. So that's important. And then we need to document your training. And some of that can be paid through the company or the organization that you work for. But, we're always required. And, I think this industry forces you to always learn. So it keeps you fresh with that. Okay, taking notes during examination and then also validate your tools. Okay. So let's see if the hacking cases, so that I forgot to check this, but let's do it now. So we can click this link. You can press Control key and click it, or copy and paste the link. I'm using 2 computers, so if you press the control and click the link, it'll take you to the site. So this site contains a lot of different data sets, you see? And I use some of this in my classes too. So here's the hacking case. Now, some of this, a lot of them, could be based on real cases, and then some of them are just, arbitrary case for practice. It's always good to kind of, and then some of them are used in like contests. And there are other websites that you can participate in for forensic competition, and it's kind of fun, right? If you guys are interested in cybersecurity competition, you can check out National Cybersecurity League. They have competition where you can practice in a gym. You don't have to have a lot of experience, right? So we're gonna go ahead and click on this one, hacking case. And I want to introduce you to this in case you want to practice another time, right? This is provided by NIST, which is an association that's, nationally supporting cybersecurity in many different ways. So what you see here is you can download, right, different, the images. You see how they have 1, 2, 3, 4, 5. So this is a set, right? So in some cases, when you are looking at the images, not just one, we have to examine this one, and this could take us hours. When we're done, we got to go to the next one and the next one, right? So if it's a very large image from a server or multiple servers, they would chunk it up like this. Okay?
Is this a government,
Funded, yes.
this,
Mhm. Let me see. I think they moved some of their information, so. Okay, well, it's really short. It's right here. You can answer the question. It says on September 20th, 2004, a Dell CPI notebook computer with the serial number was found abandoned along with the PCMCA. Who knows what this is? If you took CIS25, you should know. So back in the day, we didn't really have wireless adapter built into our laptop. We would use this, think of it like an external adapter that you can connect to the network, right? So this laptop was left, and there's a wireless adapter card along with a homemade antenna. So we can answer that question. When did the incident occur? What date did it give you? So put down the date. Let me see if we can expand. Yeah, they took away some of the information already. Well, anyway. Display external link. I think it's just because they modified the database. So you're only getting the short description. It used to contain better description than this. But the point to this, why am I, so before you approach a case, right? You kind of have to interview and gather some general information about that case. When did it happen? Who did it happen to? So if you're not able to answer it, you can just put no answer, right? How many images is needed for this investigation? So you can see from that website, I got 1, 2, 3, 4, 5. So there are 5 images that I need to download to investigate this case. Actually more, I'm sorry, click the arrow. Click the little arrow to the right. So 6, 7, 8, a total of 8. Now you notice that the extension to this is DD, right? The first 8 is DD because it's they use DD, we saw that in another lab, to create these images. So when you downloaded these images, you need to use the same application to open the image, understand? So I cannot use, unless the forensic toolkit allows you to use that file extension, then you can. So we would need to use the same type of application to access the image. So that means that if you physically gather this image, right, you make an image using DD, you put it on a storage, you should copy it and then examine the copy. Because if you mess up, you can go back and recopy it again. But if you examine the real image that you captured, if you mess up, then you have to go back and recreate the image. And sometimes you cannot, because that system was lively connected, and then after we image it, we had shut it down so that way we can physically relocate it, and so on. So now you notice that the subsequent image here, it says E01 and E02, and then you can go to all the following pages. It's just a different file format for the same set of images. So the data set, you're able to use DD to access the image, and then you will be able to, and then they have a .log file. So logs is so important in cybersecurity. Logs will tell you what had happened. It's kind of like an event recorder, or like a camera system that records everything that happened to that computer or that system, right? So log. Now downloading, I'm just warning you, downloading images, because they're big and they're distributing from maybe a cloud storage that is lower, so it will take you some time to download it. Okay.
How did you figure who the suspect is?
Yeah, they took away some of the information. It used to be here. Yeah, they reduced this, so you can just put no answer. Well, the suspect we have to find, right? So with that, we have to examine the image. So what tool, and I put this answer already, right? What tool can I use to examine this image? We can use something like ProDiscover, which you will be using down the line. We can use DD and other forensic toolkit that allows us to read DD images or E01. So ProDiscover, you can read DD and E01, E02 files. So if you use if you use that tool to create the image, that's that tool that you're gonna need to use, or a toolkit that contains that tool.
Is this in the notes?
For the ProDiscover.
The photos can-
I think earlier notes, like the prior chapter. Yeah, when it talks about tools, last week or the prior week. And then sometime you would see something, when you see FTK, that just means that forensic toolkit, but someone has also copyrighted and trademarked that FTK as a brand. But if you see FTK, it usually refer to forensic toolkit. That means that it has a lot of tools within. I have a tool to create image. I have a tool to do web analysis, so it's just a group of tools that's inside that kit. Okay, and then to validate your tool, you can find this on your notes as well. We saw this last week. So this, after you create an image, right? This allows you to examine, or I'm sorry, validate And this is from NIST. So it shows you what kind of testing they've done, right? And then how they support the tools that they validate. So if I'm using a disk imaging tool like DD, right? Or Pro Discover, I would need to go in here and check to see if NIST has validated it. But I cannot purely rely on this, right? So I have to use the tool multiple times to produce the same result. Okay, but this is going to be the foundation on how you see if that tool is adequate. Okay, so it tells you to visit the link. Right, you can find this on the notes from last time, or also the notes this time. I put a link on this there. You can just also search NIST computer forensic tool testing. Now the extension for this is the disk image. So we can go to this link to look at disk image tool testing, but there are other areas, right? So when I say create an image, what does it mean? It's just a capture of the system software and configuration information at that moment in time. So let's say that I have this computer and I want to see what kind of application and what kind of files it has. I can take an image of it using another software. So what it does is it takes a capture of it, and it would list the operating system. It would have exactly what I have on the current computer, so I can examine. And why is that important? Because it could be that system that the user is using, maybe to research, weapons for a crime, let's say. Or I can take an image of a smartphone, because that way it would have text, images, and all of those things that's stored on that phone, right?
So, is it on the notes?
It was on, so the general link for validation, yes, it's on the note. But you can, because we're validating the Pro Discover and DD, you can Google search NIST, right? Forensic tool testing, disk imaging, and it will show up. And we'll come back to forensic for disk as a storage, like your micro SD, your hard drive, your SSD, and so on. But simply today, we kind of look at the case and how we can validate some of the tools that we might use to investigate that case. Like Pro Discover is a tool, or DD is a tool. So the case gives us the laptop abandoned, right, with antenna and homemade antenna and an external wireless adapter. So that means that we need to take an image of that laptop, right? First, we gotta take a picture, we gotta do the chain of custody procedure. Then we would take an image of that laptop to really examine, because we need to find out who that laptop belongs to, right? Could that laptop relate to something that's bigger? So going back to the fire line case, right? They were saying that the evidence that they got for the case could be pointing to other fire cases. So they can't release some of the information publicly now, right? So that is classified information right now while doing the investigation. So you also need to protect your data, your artifacts, while you're doing that, right? Okay, so the data set, the NIST website is there. We talked about that already. Okay. And then in the next section, it talks about how you would have use a sterile media for forensic. When you put data inside it or you using it to store your images, you gotta make sure that, you know, it's not contaminated with other things, meaning that you would only use it for the forensic process. And sometimes you have to encrypt it and password protect it, right? Let's say that I put it on an external USB. I have to physically protect that external drive. And I also need to logically protect it. So I would maybe enforce some authentication to it or using encryption, like BitLocker. We don't mix up data. A lot of times you do one container per case. So if you're using a network drive, right, a network folder, you want to create subfolder and keep it organized. Like we talked about that when we did the Linux lab. We want to make a directory and we put our case file in it. We don't mix up case files, okay? Because the more organized you are, the better it is, because that case might be very big and you might have a lot of data. So no commingling data. Okay. And then when you're done, so even before you use the drive, you gotta make sure that you wipe it clean. It shouldn't have other things. Even the warranty information, you gotta get rid of it, right? And then when you're done, you have to sterilize it. So going back to the company, let's say that you work for the company, how long should you maintain the data for that case? And then once you do that, you get rid of it. So here it talks about, you know, and then the storage physically, right? We gotta wipe the data before we throw it away. We don't just throw it in the trash because as you know, flash technology, pieces of data remains. So you cannot just throw micro SD and USB and things in the trash. Even if you right click and delete the files, right? It goes into Slack space and you can still find it. So here it talks about how you can sterilize it. Some of the toolkit has equipped, you know, feature that you can use. You also use hashes to verify file only, but you cannot use hashes to verify the sterilization process because hash is only used for file integrity. Okay. So Paladin is one that the toolbox has a lot of different things that you can create images, you can convert forensic images, and you can sterilize your media. So that's all in one software toolbox. Okay. So 7, why should you use sterile media before starting and at the end of the forensic process? So that way we don't have the capability to create a forensic image. So why? It's because if you don't have the opportunity to create an image, let's say that that image is given to you by another person or a group of people, you were forced to create the forensic copy to perform for the examination. So we want to make sure that we start with a storage device that is clean, that doesn't have anything on it, that doesn't have other data, right? Because if you didn't create the image, even if it goes through the chain of custody, you gotta make sure that there's integrity in that image. I should say when instead of why for that question. At the end of the investigation, the evidence case information must be removed through the sterilization process. We don't just delete the file. We have to sterilize the media. So that means that it's zero out the data, right? and you have to do it multiple pass. So the software is designed to sterilize it in that it wipes the data multiple times, so there's no remnants of anything on that media. Because that could impact the next case that you store on that same media after sterilization, right? So we want to make sure that we have that in place. So what can we do to verify if the media, if the storage, if that USB, if that container is sterilized? You can use checksum tool. So the toolkit, like Paladin has that, right? That component, that feature. But if I don't have a tool set that has that, I can locate a 64-bit checksum application or tool to validate my media. So let me scoot some of this up because some of you are still working on the prior questions. So what tool can be used to sterilize media? So Paladin Toolbox, you can use that. Another one that you can use for validation is X-Ways. You would use that for media validation that it has been sterilized. So those are just two, right? You can find others in the industry. And then there are new ones. There's some that you have to pay, they're proprietary, and then some open source. I wrote a lab for Paladin a while back, and just running it here, there's limitation with USB boots and all of those things. So, but you can also check out their resources. They have some tutorial, and I think there's a small fee that you can provide to get Paladin. It's about $25 or less, I believe. And it runs Linux in the back. So before we attempt the tool, we want to read more about it, how it's used, how to install it, what kind of system requirement does it have, to see if we can even use it on our system, right? Is it a virtual machine? Is it a live virtual machine through USB? I think Paladin has multiple options. And then they also have sub-tool sets that you can also obtain instead of getting the whole toolbox. Any questions? Okay. So pretty straightforward about some of these tools. I think I wrote some instruction on using X-Way. So down the line, we'll use some of the toolkits and so you will be able to see. I hear some of you still typing, so I'll give you a little bit of time. Okay, so this section, right, it talks about, and then you can also read more about the tool. And in the next page here, on the next page, it talks about write blocking. So write blocking is a way that we can prevent that storage device or that disk from being altered or having additional things added to it, right? So let's say that I create an image, I put it on my USB drive. I would use a write block software, or it could be a device to make sure that that USB drive stay intact and it doesn't change and nobody else added the file and so on. Okay. So there are two options that you can go with. The hardware, which is a device, and all it does is it intercepts and prevent any modification. So let's say that I'm using this device, I'm attaching my disk to it, and I connect it to my another computer attempting to add more files to that disk. It will prevent it because it's gonna see what kind of file that's being transmitted or trying to be written to that drive. So you have to physically connect this device between the computer and the storage device. Okay, so it's like a hardware component that's connected. You can also use the software. So there are some that are created for Windows, and then you can also find tools that are for Linux and other OSs. So the goal, right, in write blocking, why do we do it? Should be used. It's to prevent alteration of evidence of your data set or artifacts that you have gathered from the data sets. So where your evidence sits, we want to write block it. Where your evidence is stored, we want to write block and make sure that that doesn't change. And then for 11, I just need you to search the internet for two devices that are considered write blocker. And that's really easy. You can open up Google. Let me move my Zoom bar. Let's open up another tab. And then we can go and we can say write block device forensic. And then if I want, I can go to shopping and I can find. And they range in this, the price is gonna be, and they do have some of the cheaper ones, but you normally see that they're like a few $100s. And then this one, Tableau. So this is a bridge device, so it can be integrated, so you can find some, and then even on Amazon. So that's what they kind of look like. So the whole purpose in this, and then if you go down a little bit further, you can also, Blockbox. So it really depends on your media, what you're using it for. So Tableau is a common brand that you see. So let's say that if I select this one, that could also be bought from Amazon. So you can pick a couple that you find. Just make sure you look through it and it makes sense, because sometimes Google search gives us other things. Like, this we don't need. So find two, and I simply search write block device forensic, and you can find it. And then we can also narrow down by cost and feature, right? Like CRU, does that work? So you want to look for the device that would make sense, that can be used with your system, right? And storage. And then you can also see if the main company, the website that produced it, if the company have a website and you can read more about it, or sometime it would be through the vendor. Okay. So pretty simple for that. And then once you find it, just put the URL, two URLs for number 11.
Did you put on there, write block
Device forensic. Any question? Show up. So on the Windows system, how can you enable setting for right block? Right? You have to change the registry. And what is a registry? It's basically contain lists of hardware and software settings, configurations, and different things that would make the operating system work. And when we modify, so when you install a new software or a new hardware, that gets added to the registry, that the information or the registry key gets added into the registry. So if we want to enable the settings for right blocking, we need to go into the registry, look for that registry key. Usually it would say H key, blah, 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 right? Under the tree, under the expansion of the registry, and be able to modify the setting. And that will allow us to disable anything that's attaching to our disk or the USB storage. So your whole point is to make sure that nothing gets connected or attached to your storage drives or your USB storage. So if I plug in my external USB drive, right, and nothing else can connect to it, only that system can be allowed, right? Even that system is connected to it, it cannot write to it, cannot add or store additional. Any question?
Number 11,
Just put the URLs for each one. So the link from the website, you can copy and paste it in. Does that answer your question?
well, I'm trying to do this, but it won't copy and paste this one. That's what you, right?
Well, you have to click on it. And then, so go back. Gotta click on it.
On this.
Go down. Yeah, and you gotta select it.
Select this one.
Yeah, whichever one that you think is the right blocker.
You want the picture or just the?
No, I want the link. So click on it and then copy the link and paste it onto your document. Other questions? Okay. So next we'll talk about forensic image and the logical image. And forensic imaging section is on, it's like the middle of page 4. So when you're doing a forensic image, basically you're taking a bit and you copying it to another storage, that same bit. It's bit to bit copy. Okay. It's not too common, but it is an option in most forensic imaging tool. Then So forensic copy means bit-to-bit copy. That's uncommon. Now, forensic image, it also creates a bit-to-bit copy, but we store it as an image format. So this is a little bit more on the raw data side, and this is going to be image format. So earlier, when you look at that hacking case, when you see DD image, E01, E02, that's a forensic image. Okay? That's more of a common use, right, of system copy. So if I want to investigate this computer, I want to create a forensic image of this computer. Now, forensic copy, it's just a bit-to-bit copy, but it doesn't have that format. The logical forensic image is only accessed with specific data sets. So let's say that the example that they give here is like a live server, like maybe a web server, and you're trying to investigate it. You're going to look into the data inside that server. That's a logical forensic image. We cannot create a bit-to-bit copy or a forensic image. Then we have to make a logical forensic image. That means that we're just getting a subset of that data set. Okay. All right. So here are my answers. So forensic image is data file of bit-to-bit copy of the source drive. The logical forensic image is a specific data sets of the source drive. So for example, from that server, I wanted to look at, let's say, web content from that web server, like HTML files, right? Then I pull logical forensic image and make a copy of that and put it onto my storage. The forensic image we talked about is a data set that contains bit-to-bit copy of the original system, the entire system. It has application, OS, files, everything within. Where logical forensic image is only the files from that system. Let's say that you only want to look at pictures from the smartphone that was confiscated by the police, right? Then you create a logical forensic image. But if you want to look at everything on that smartphone, then you have to do a forensic image. It contains everything, right? Like my phone is an Android, so it will have the Android OS and it would have all the application I installed. So forensic image entails the entire system data sets. And the common formats that you see is DD and the E01, E02. So the number after the E just indicate the subsequent image in that set. So you have to go through sequential order, right? Because we're limited to size. If you're gonna see that when you create an image, it takes a long time because it's bit-to-bit copy. So imagine if it's like 500 gigabyte or 1 terabyte, right? And it also depends on your processor that you use to do that copy. So if you're using a powerful system, it's gonna be standard or somewhat decent in speed. But if you're using an older computer to do that or an older processor, that's gonna take a long time. So what we do is we chunk up that image into, you know, smaller storage, smaller files so we can use it. And easier for us to copy. Any question?
just need, to go back to that real quick. Question 13.
You can find it on the notes, so you can summarize it, or
I fixed notes in that section.
you can re-download it. So we'll have another lab that we'll do. You saw a little bit of like the USB imaging with DD already, but we'll do another lab that we would use a forensic toolkit, a software to create an image. Or we would use a data set from NIST and you would see it as a forensic image. So we'll do some Android and iOS investigation later. That will be fun. And then Drive for file carving. Okay. So before we go to next one, go down on your notes, right? It talks about the DD image here. So some of the features that you would see on this tool, it's able to create hash. You can wipe disk, and then you can split. Remember, we saw the E. So some tools will allow you to split the image into different files. And then it also create a logs. That's important. So I list some of the tools here for you, so you can find Encase is popular, DC3DD. So Encase uses E01. Okay. So with solid state drive, right? It is a little bit different than your normal traditional hard drive. Okay. So knowing the technology is crucial. Understanding how the solid state drive works is important because it tells you here that it will create some issues with digital forensic. Now, it automate with the firmware because for flash technology, right, that's how it's used to store. So that runs in the back, and that is no way that you can change the nature of that technology. So that means that when the blocks of the storage device is overused or not equal, it can lead to failure of the storage block. So you might run into that problem. Firmware will decide where the data is stored. So remember that flash technology, it is fast because it's able to put things dynamically, right? Like if I have a carton of eggs, in flash technology, it's just gonna throw it into the empty slot in that cart. But in the sequential drive, how we store things traditionally, it's gonna go from 1 to 2 to 3. We don't want that in dynamic storage. So the firmware that they wrote is really, it has an algorithm on how the data goes on the solid state drive. Okay. And you have the option to trim, and you see this in Windows operating system too. Sometime that you need to clean up your drive, right? You can trim it. So the firmware allows you to clean up the garbage on your storage by using the trim feature or the trim command. So the deleted data goes into a slack space. So in flash technology, when I delete a file, it just makes that space become available. It doesn't go away, right? So when I use the trim command, what that does is it's gonna use now that space to put it back into free space. Okay, but if it's not trimmed, there's still remnants and traces of that file, and that becomes the slack space The slack is the deleted stuff where it goes, right? That space, just the available spot that originally stored that file that I had. So it is possible that after you do the forensic image, you have to do a pre and a post hash values for the source drive just to check its integrity. So if you have a different value, right, then you know that there are changes in that drive compared to if you have the same exact match, then that storage stays intact. There's no changes. Okay, so you have to do before, let's say before we have 1, 2, 3, 4, 5, after, right, 6, 7, 8, 9, 10, then I know that my image is stored there. But so there's something that needs to be noted with SSD, and that's important. Okay, so for 15, it says, what type of issues forensic examiner might face with solid state drive, your SSD, which is very common. We use that now in our systems. Some blocks are overused and they are not equal at the hardware level, which can lead to failure. And this is what you see when you use your USB continuously or your solid state drive over time, right? You got a lot of downloads, a lot of files, you install a bunch of things on there because blocks are not equal and they get reused and overused over time. It's wear and tear, basically. The firmware for the solid state drive will decide how they write the firmware, where the data is going to actually store on that storage drive, on that solid state drive. And when you plug in your drive, it will activate the firmware and it will move things around because the firmware, its job is written to say that, oh, well, I might have file 1 that was stored in this spot, but when you plug in the drive again, or the drive gets powered or used again, it would then move it to another location to make room for new files, right? It doesn't necessarily stay there permanently. So it changes the physical location of that file, or even on the logical side, we see that it changes the nature where that file is stored. So changes cause issue in integrity for our evidence. So we gotta make sure that we know that, right? Sorry, I have a lot more, but let me move this question to the next page. And you don't have to put it verbatim, right? I want you to understand the concept more than just typing exactly what I had. So for the trim, we talked about trim command. So when the user delete the file, that section of the drive or that space doesn't get trim until the trim is issued, okay? Now, when you're using the trim command, right, so what it says that this causes the now unallocated space to be wiped. So when you trim, the unallocated space that used to store your file that was deleted, it's now going to get wiped and the deleted data is no longer accessible. So when you understand this, when someone right-click a file and choose delete, put it into the trash can or the recycle bin for Windows, right? Or the OSs, the system just take that space and said, oh, it becomes unallocated. It becomes available for the next file. Now, if I use the trim command, what's going to happen is it's going to take that space. It's going to clear out the data, right? And the deleted file completely goes away. It wipes it. Now, someone can do that, right? They empty the recycle bin and then trim the drive so that the deleted files might not be found. But that is questionable though. When we do file carving, sometimes we can find that it depends. It might still have the file type that used to go there, but not the file intact. Right, so when we're looking to unallocated space, it will say, oh, there used to be a photo image that used to be here. Sometime it would tell you like the file name, right? And the size, but it cannot retrieve everything. And then for the large drives with long imaging time, we want to use hash values. And before you image, right, you have a one hash value, and after you image it, they're different. So, and then also drive has idle time for the image process. Solid state is definitely fast and it's more reliable than your traditional hard disk drive. But definitely consider, technology has its benefit and flaw. So if we know both areas, we can address some of that through our procedures. Okay. Now, most software, when you use software for like forensic toolkit, it always start you with a case number, right? Case number is just an identification number that we use to be able to locate the case, to store the case. So on your report, it's very important that you include your case number. It is just an identifier for your investigation. And you can just create a schematic way to put a case number, right? Like 001, right? You can start with the first case, or sometimes you would use unique ID with letters and numbers. That makes sense in your organization. And then you have evidence number. Because evidence can be many different things, from physical system to files to web communication to network traffic to other things. So as you gather your artifacts, you would give it a value or an identifier as well. You would put an identifier, so that's going to help you track, because you might have thousands pieces of evidence. And it also helps you organize and categorize the type of evidence that you have. So 15, you can find that on the notes, and also 16. And then we want to put down evidence description, make, model, capacity, meaning like the size. So if I have a micro SD and that micro SD is 64 gigabytes, then that's the capacity, right? And then serial number. So the more detailed description you have for the evidence, because you might have 10 micro SD, right? You want to differentiate between one to the other because each one might contain different files or belong to different people. So as you go through and investigate, you want to take this, put this down on your notes for the investigation, your documentation, because that's going to help you build the final report at the end. And then additional notes about that device. Description can also be like color, other things, right? The characteristics of that particular device or system. And then notes.
So. On this, on my. Campus, it only goes up to 16. So, um, um, this is totally different.
I'm on
But, see, I don't have 17. This one just a blue one.
I'm on number 16. There are only 16 questions. I don't know what you're referring to.
Really?
Yeah,
Oh, okay.
I'm on 16.
Good. All right.
Now, some of this gets integrated into chain of custody forms, and that's helpful too. So you can correlate all the information across, right? Your documentation for your investigation should align with that. Yes.
I don't see that.
For the notes,
Yeah.
I'll come back to some of the drive technology. It's on the last page. 7. So, coming back a little bit to the imaging tools, right? Earlier, you guys have to put down like the type of tools, disk image that you had. Where did I get that information? Well, it's on page 6 and 7. So you can find FTK Imager, right? And then there's DD. You also see the type of images would be SMART, right? E01, AFF. We saw some of that from the earlier notes. AFF stands for Advanced Forensic Format. This is an open source. I don't see this as common, but you do see it sometimes, right? So we know that it's there. And then after that, we would document our tools and investigation process. And this is where we left off with 16. So go through the notes again, look through it, and then look through your answer so that way it helps you remember, right? We should have an upcoming quiz soon. Yes, Gabe.
Did you leave that up there for me?
Yes, and you can find the same exact information on page 7 of the notes. Sure. Okay, so I'm gonna stop the recording. We're gonna take a 10-minute break. I know it's right earlier, so that gives you time to get started with your lab. You will need a drive for your lab if you haven't gotten it. You just need to copy it to your desktop. Do not run it from the drive because someone else will use that drive the next time. So just drag that folder, right? The CIS27A forensic VM folder onto your desktop. The procedures are listed there for you on lab 3. So download the lab document when you come back from break. Okay, there's snacks and then bathroom, and then I'll open the door for water if you need. So let's stop recording.